Welcome to the LemnaTec Academy. In this video, I will explain the software architecture of the software used by the LemnaTec systems and devices as of the 2022 generation. In the previous videos about LemnaGrid, we converted our segmentation-based binary image into objects, and this automatically calculates certain properties of these objects. Properties like area, convex hull, caliper length, minimum and closing circle radius, second moments, but also compactness, roundness, and so on. All these properties have one thing in common. They depend only on the shape and size of the object itself. Therefore, we do not need to add any further information to get the intended results. However, other parameters may depend on additional information, like the color of the original image or association to certain region of interest. Therefore, we need to add this intrinsic information to the objects through dedicated devices. Since these devices combine external data with object shapes, these objects must not be altered afterwards, except for adding more intrinsic properties. In other words, these devices must be the last devices prior to the writer device. But let's look at them in LemnaGrid. Let's start with the grid we have developed in the last video. We find the devices that add extrinsic properties in the image object section and their inside properties. Some are more useful than others. Let's discuss them one by one. Calibration. This device works only with old LemnaTec systems. It requires some information stored in their database. You can achieve a similar effect using the formulas in Lemna Experiment. Color classification. This device can be used to create classes based on color in the image and calculate their abundances. Check the next video for more details. Distance property can be used to determine the distance of objects to some reference. Histogram CC. This is similar to the color classification, but the classes you create are based on a histogram created from a grayscale image. Image object region of interest. It is used to assign well names to objects, as we have seen in the last video. Mean color property can be used to calculate average colors or grayscale values. Skeleton info. Add skeleton information to the objects. You need the extended properties writer to save these data to the database. More on skeletons in later videos, in particular in class 4. Unique label creates a region of interest name, aka well name, aka position name, for each object derived from the position of the object and its size. The image object region of interest device, mean color property device, distance property, and color classification device are those devices which you will probably use most. Let's discuss a few of them in more detail. We start with the image object region of interest. If we look into the options for the tooltips on both sides, you will notice a difference. On the right, you find the region of interest affiliation, which is missing on the left. This is the extrinsic property storing the name of the region of interest, aka well, aka position. The next device we will look at is the mean color property device. First, we need to add it. The mean color property device has a second input which accepts a grayscale or an RGB image. This device calculates a lot of statistical data for each color channel. This includes the mean value, the variance, quantiles, and so on. In addition, the mean and variance for the channels of the HSL color space is added. However, if you use the usual objects writer, as we do here, only 6 of these values are actually written to the database, the mean and variance of each RGB channel. If the input is a grayscale image, we still get 6 values, but we have only 2 values which are different. Since the original data is grayscale, the means and variance is the same for all color channels. However, this still can be useful if we need to measure some calculated values with some more complex cameras, like PAM or hyperspectral. We will use this in videos about these cameras in class 4. Let's return to the single plant example of the last video. Here we don't need to add any row affiliation whatsoever. But let's consider, we want to measure the height of the plant, including the stem and anything else, even though we didn't include them into the objects. In this case, we can use the distance property device. At the moment, we just see the objects but nothing about the pod or the stem of the plant. So we need to do something here. This is now a good time to introduce some other feature of LemnaGrid. At each device, we may add an additional image data stream to the visualization. We open the context menu on the device by right-clicking it and select Add Visualization Box. Then we provide a name to this port, let's say RGB, and another dialog opens. Here we can determine which of the images available shall be the base layer, called solid, and which shall be an overlay. In this example, we have the input objects, the output objects, and the RGB image we just added. I like to have the RGB image as base and the output objects as overlay, so I move things a little bit around. Now we've got an extra port at the bottom. These ports at the bottom are ports which are not used in any kind in the image analysis, but only for internal visualization in the device. Now we need to connect the original image to this bottom port and open the device. Now we can move around the horizontal bar and place it, for instance, in the middle of the soil. This gives us again additional options in the tooltip. The area distribution horizontal divided and the max distance from horizontal line. The latter provides us with the height of our plant, even though we didn't catch the stem in our segmentation. You can use the vertical line or a point as reference as well. We will discuss the color classification device in the next video. A few remarks on intrinsic properties. As mentioned before, these needs to be the last devices before the writer, and manipulation of objects after them will remove all the intrinsic property values currently stored in the objects. If you add the same device twice to the same object, the second will override the values from the first. Object writers will create result tables, including all columns for all extrinsic values. However, if you didn't edit the respective device, these values will be just some meaningless default values, usually 0. Which data is written to the database depends also on the writer you have selected. LemnaExperiment supports 12 out of 15 writer provided by LemnaGrid. The basic writers are the objects writer. They came in 8 variants. We have 4 normal object writers and 4 overview versions. These overview versions report only a limited set of columns. You can find which these are in the documentation of this device. We have 4 object ROI or region of interest versions. You need these if you have more than one sample in the image, as we have seen in the previous video. We have 4 objects CC version. CC stands for color classified. You need these if you use the color classification of the histogram CC device. We will discuss them in the next video. The extended properties device is a version of the object's region of interest device, which reports more data to the database. We have 3 more writer devices which are related to the skeletons, which are mainly used for root analysis. The data dictionary, hyperspec mean value, and intermediate writer devices are not supported by LemnaExperiment. If you have further questions, please check the other videos at lemnatec.com/academy or on our YouTube channel. Or contact us at academy@lemnatec.com.